Right, well, we're going to start. Hello, he's Dmitry.
And this is Duncan.
We gave a talk last year on refactoring. We got some great reviews. He got some mixed reviews. Okay, they got worse. Did any good ones? Okay.
Yeah. Sit closer to the door if you're not sure.
Funny. Oh, I like that one.
Didn't came for jokes, right?
Nice. Very funny. More refactorings, but nice jokes. That suggests that, less refactoring would have been good. I don't know. Inspiring. Loved it. We've missed my favorite, which was, that was bollocks. This year, we are doubling down on WTF was that. We are attempting a refactoring speedrun. Can we manage 47 sequentially refactorings in a single code base in 45 minutes?
What is refactoring?
Come back to that. Why 47? Well, we felt it had to be more than one a minute, and 47 is prime. Probably?
Yeah.
Yeah, sounds it's prime. So, we picked 47. Rehearsing it turns out to be quite ambitious, especially if you waste a lot of time in this introduction. So, what do we mean by refactoring? Well, you know what refactoring is. That's why you love IntelliJ, right? We have a rule, okay? We're defining refactoring as a source change in the code from the code is working to the code is working.
Green to green, yeah.
Yeah, green to green, right? Shouldn't change behavior. We've got lots of tests. That's good. Quick fixing broken code's not going to work, not going to count, but quick fixing a thing that changes the code, we're going to count that. We're only going to count the first one of every refactor, though, right?
Types of refactorings, right?
Types of refactorings, yeah, that made it harder. Okay. I think we should say, like, source refactor, like just changing the formatting doesn't count, but something that changes the compiler abstract syntax tree, we're going to count that.
Oh, we have one.
Not just reformatting and reorganizing imports, those, that sort of thing. We have Ivan Sanchez, our glamorous adjudicator. He's going to keep score on the laser display board, and he's also going to let us know how we're doing for time. So, Ivan, how are we doing for time?
You wasted 3 minutes already.
Okay. Okay, so, Dmitry, should we crack on?
Yeah, so...
I'm going to ding the bell when we claim one. If Ivan agrees, he's going to write it up on the board, and then it's going to go up, and we'll see how we're doing.
Yeah.
Okay, are we off?
Yeah.
Go.
This is a file we spent in 45 minutes last year. So let's just look away.
Okay.
And this is the code base you've been writing on YouTube for 2 years now?
3, probably.
3? Okay.
Let's driven Gilded Rose.
Yeah, so I had a look, and I thought maybe we can have a quick tour and tidy up while we go.
I think we should.
Yeah, as an overview.
Refactor to understand. Close it.
Don't. Right, so I guess that's the entry point, main KT. First thing I would do, just run tests, and then I would reformat that.
Doesn't count.
Yeah. Then I would start a main file with main KT with main function, so I'd just move it up.
Move.
Yeah, then I can see it uses dbconfig, which uses environment, so I swap them around, so we have high-level abstractions first.
You moved first, yeah, okay.
But that doesn't compile.
Okay.
We could fix it by converting it to getter. But there is another option to make it lazy, for example. That will work. But I'm not that desperate, so I'll just undo this.
Okay. Undo doesn't count.
Yeah. I also think the environment could be private, because it's not used elsewhere.
Did you use a refactoring to make that private?
Right. Let's go back. There is change visibility.
Excellent.
That's K2 thing now. There are more pop-ups.
There you go.
Right. But it turns out it's the only usage, so I have this rule. If something's used once, I would try and inline it and see what it looks like. So I think this is better. Right?
Yeah.
Let's commit. Oh, by the way, I'm committing without dialogue. Genie will write commit messages later. And then there is environment kind of duplicated here, and there is environment env, which is repeating itself, where env is really system env. So I would try and import things here. So do this and reformat like
Changes the source, doesn't change the class files. I'm going to claim it.
Yeah.
Okay.
It's allowed. Oh,
Yeah.
it's allowed. Thank you.
Yeah, and this like now makes me think if there is JVM properties override that, because it's a short annotation, makes me think maybe it should be local env or something
Extract
like
local variable.
that. It's property, but yeah. So yeah, we'll make it private, and I think
got
this
that
is
one,
good
yeah.
enough, right? I think.
Nice. How are we
Then-
doing? Do we agree on 7? Brilliant. Thank you.
And then going back to main, there is dbconfig. I think it doesn't have to be like that. Can remove name.
I think that is yes allowed. Hold on.
Yeah.
He's doing it. It's fine. Yeah, following my rule, like app is used once in main. Like, why not try and inline it? And I'm not sure if this
had
is
it
much
inlined
better.
already?
Yep.
We did inline. Yeah.
thank
yeah.
you.
Yeah. So I'm not sure this looks better, right? So maybe I'll just undo. And I'll look at server 4 because this is not part of HTTP4K. You defined it here.
It's just a function.
Format.
We're using it in tests, I think, so we want it defined in one place.
I think what it's doing is like passes ports through routes, and S server is part of HTTP4K. So it's really all it's doing is just undertow. And I think it's a bit confusing. I would keep it in the same shape as the S server, which
Right.
is built in like. So I would do this, convert parameter to receiver.
You've taken my favorite refactor, and you've taken it from me, but we'll claim it.
Yeah.
Okay.
So, but then it's used in a few places. So, like, we could inline it, but it's like, good to encapsulate the type of server you're using, right? So then, what it gives us, though, we can inline the app now here, and it looks a bit nice, I think.
Yeah, I agree.
Right?
I mean, maybe even drop that roots down.
Okay.
I'm all over that. Not really a refactor.
No,
just
refactor.
formatting. Yeah,
Maybe you
okay.
could rename server to server on.
Have we done a rename?
No.
Excellent.
So I think that was enough of this one file.
10 refactorings in one file. Good man.
I guess let's just to explore what else is happening in the app. We can navigate to how the roots are defined. And you were, with formatting, empty lines. You were clever by what roots are is an extension property with the getter on the app. App is domain, and this is HTTP layer, so if you don't know, that's HTTP4K. Function, which gets request, returns a response, and there is a filter which wraps handlers, and now you know HTTP4K.
Oh, you all know HTTP4K. Well done. Collect your certificates on the way out.
Right, so what you're doing here, you're setting up some filters like handle errors and something analytics, and then these are the actual roots of your app. I would do this personally, but it doesn't count. I think we've done that.
No.
Right, and then what are the roots? I think this root, error, I bet you added it just for testing.
I did.
So I would add it at the end, so that's like, it's a bit of narrative. We can get things, then we add items, and then we delete them, so it's more.
Okay.
Reordering. It's okay.
in Varrogs, yeah?
Yeah.
Thank you.
Yeah, I would also maybe reorder the functions here. We kind of done it before, but it's easy. Like just move things around, least add.
Yeah.
Yeah. Cool. I think one other interesting thing here. So if we actually look what list handler is doing, I'll reformat. It's a function which has a receiver, and it takes request and response. And well, it goes like loads stock with the result, and then it renders it. This is result type, which is not a Kotlin result. But,
No.
Yeah. But the interesting thing here is that it's used here as a reference. Oops. Here. To the to function, but this function is taking HTTP handler,
Right.
which literally a function with one parameter, but
Yeah.
we're using this with two. It's like, so to explain it, so converted to reference,
Lambda.
that's a refactoring. Then you can see clearly it takes one request, one parameter, and returns a response. But this function here, list handler, when we convert it to reference, for example, here, it actually has two parameters, but it works because it's defined in a getter of extension property. So I think that's really clever.
Whoever
You should
wrote
get
that.
should get a badge for that,
Great.
some kind.
Very much. Oh, so kind. Bless you.
Yeah. So yeah, that's the root. Let's go back to main. Finally, look at the app. So, well, I see a yellow thing. It says declaration type.
Okay, that's a quick fix.
I'll fix, yeah.
Yeah, it's changed the code. Change the code.
Yep.
Good. Thank you.
And I'll move them down, because why not? So then in the app, if we start looking at it, I think what we call, there is a constructor and there is a secondary constructor. So I think this one is what we use in main files, whatever that means.
So that's
and
like convenience, I guess.
Yeah. I think what I find it funny that there is a very specific URL here for like some service which does prices.
Yeah.
So maybe this should be like live outside of this class. For me, it's like, which one should I read first, this one or that one? And I cannot decide, and it's like, maybe we move it out. I have my own refactoring, because I wish they were. You see the monkey. So.
Do it.
Yeah.
So you can write your own refactorings, folks.
Yeah. And should we move it to main, because it's used?
I think so, because that would then uncouple app from dbconfig and a bunch of other things, wouldn't it? That would be nice.
Cool.
Yep, you moved.
We've not done a move.
We've never done
Different file?
Yeah, oh,
no?
Thank you.
Right, let's commit. And here I find it interesting that DB, all the parameters have defaults, right? And that's your production configuration, except for dbconfig. But when we look at usages, it's always dbconfig anyway.
Right.
So why not have this? Well, it cannot do this, but we can go here.
Well, you can move it up and then do it, couldn't you? I guess.
We can copy the value, I think, like that. That will do.
So that sort of replace I don't know what,
Replace explicit parameter with default to make it consistent with other defaults. I don't know why you did it that way.
I'm not sure they're ever going to call it that in the menu, but I'm going to claim it. Yeah.
Yeah. So let's run this. And then we can delete dbconfig.
We deleted unused yet?
Yes. Oh, no.
Oh, woo.
That's new.
Okay. Right. So back to app, I guess.
Yeah.
So in the app, what do we do?
I don't remember it being this untidy.
Well, yeah, there is a track record of YouTube videos for this, I bet. So there are items, and I think this is loading things from database with a result type.
Did you reorder those?
No.
I thought you were going to.
No.
Okay. The parameters.
Parameters. Yeah. Well, yeah. So that's like the items, right?
Oh, I see. Yeah.
And then we see there are features, clock, analytics, pricing. I think my sense, this app is about Gilded Rose stock, whatever stock list. So this will load. Then we price them, and we use clock to determine if they need to be updated or something like that. And actually, I think it matches the usages where this is used. It goes items pricing clock, but this is now how it's defined here, right? So maybe it's, you can resize this with shortcuts. So yeah, maybe the order should be different, items, pricing, clock, features. I
think analytics before the features, because they're okay.
So that's reorder parameters.
If it completes, which it did, good.
Yeah, done. Let's run tests. Right, and then where items are used, they're used in stock, and stock is used in price loader. And price loader is used to load stock lists. Straightforward, right?
Yeah.
Yeah. If we look, for example, at price stock loader, it has some pricing, which is defined here. Fortunately, can it search for usages?
No. You can data flow to here.
So in price stock loader, what do we have? We have a function which will get the items, and then we price them. And that's the pricing thing. Analytics, fine. Thread pool, move to constructor, I would. That's called dependency injection, right?
I didn't even know we had moved.
You've done that one.
What?
Move to constructor, no?
Yeah, you did before for the database.
No, that was move the constructor.
Oh, for a default, yes.
Yeah.
Ooh. You're right.
But thank you for your diligence.
Tried, yeah.
Right, and then save this. Then what are we doing? Loading magic. Good.
They were going to fix
Yeah.
context receivers.
Then, the price is used once. We'll use my heuristic just in line. And then this one is used once in line and see what it does. So I can still kind of cope with this, but maybe this should be like this block, priced items, right? Here, priced, it should do
What?
variable, priced items as a variable.
Yeah.
Right.
So what's this doing? This is loading them all in parallel, is it?
Yeah, it's complaining.
I wrote the code, but it was a long time ago.
Yeah, so we should rename this, I think, to item, for example. Then
That's a new one.
Sorry?
That's a new one, right?
I think. Well, was it replace explicit it? I think it was. Oh, thank you.
Okay, if you say so.
We have slowed down a bit. I think we may have picked the low-hanging fruit.
Sure. So yeah, what this is doing is just the thread pool, right? It's doing something parallel. My guess, it depends on what you want to express, but I would maybe move like this price stock list can go out, and this block could do priced items in parallel.
That was depressingly manual, but
yes, but that's kind of changing the scope of parallelism and to emphasize that it's about parallelizing pricing, not something else.
Yeah, moving things in and out of a block.
Yeah, right now it's kind of pointless, but maybe later it will be more useful.
Yeah,
depends on what we want to do. Right. Going back to the app, so that was price loader, which uses stock, which loads and updates stock list. So actually, it loads and updates first, and then it prices it. Right?
Yes. Yeah.
Yeah. Let's look at this. I think there was something fun.
I am not proud of this.
I'm not criticizing. I'm not cross and
not
disappointed. Yeah, so I don't think it's bad. It's just like one thing. I think it's more nested than I would imagine it needs to be. And one of the tricks I try is I'm not saying you should do that, but you can replace when with if, and then it's less nested, you can see. And I also see does this need to be nested? It probably doesn't if we do an early return. To get there, let's maybe invert if.
Ooh.
Right. And then we could already do return here and do from flatmap, but I think it's not that nice. And I'll try and refactor this from result type. So let's save this. This is a result type, and we flatmap on the result, right? So again, it's more nestedness than it could be if we do more non-functional style like last one. So we can convert this to a block body. That's refactoring, is it?
Yeah.
Oh, thank you. Oh, right. Excellent.
And then
I mean, that was that ding for the one, just to be clear.
So yeah, and then I'll do the load and I do early return, and failure can return it. And funny enough, this incremental way, this works still, right?
Yep.
But then we can
You loaded it twice. But
but then we can do this, extract variable with the same name as there, and then can do return inside lambda, and then we can drop the flat map, and that should work still.
Okay, so that's flat map to early return?
Yeah, that's a compound thing, refactoring. So what we can do now is that we can replace return with, I don't think it's a good name, it's drop return into branches. You see it's doing this thing. Also
yeah, because
refactoring.
If you do it the other way around, what does it say?
Lift.
Yeah.
What's the opposite of lift?
It's drop, yeah.
Yeah.
Okay, so we had lift and drop.
Okay. Yeah.
Did you?
Sorry?
Did you do two refactors?
Yeah, we undid it with, I think so.
Okay.
Okay.
But what you get now is that you can do remove redundant else as refactoring, which is built.
Oh, nice.
Yeah, and the way I think about it now is this is some setup you were doing at the top, and then you actually do the job here. Again, this is used once, inline. Yeah, good enough. Something like that. A bit shorter, I think, deleted.
Yeah, I mean, you have to hand in your functional programmer badge, but I think it is better.
Yeah. Yeah, and that's, what does it do in the loop? I think it's getting item update, which is default to this function defined right here. Right, that's maybe item type, but yeah, anyway. I think that's kind of an overview of how items are loaded and updated. I think that's good enough. And I thought you also had some ideas how this can be improved.
I do. Let's go forward from here. How are we doing, Ivan?
You have 29.
29. Oh, I agree.
No, I have 27.
The point of truth is behind us.
Yes.
Right, okay. Right, let's have a look, shall we? Let's have a look in item type. So, let's have a look here. So, we're trying to update items. They are immutable, so we need to return a copy. And an item type is the way that we decide how to update them. So we go and fetch an item type, and then we ask the item type to update the item, and that's this fold on line 41. No, numerically dyslexic today. So let's go and have a look at Typeforce, see what we've got. Okay, so here we have a file with a file of item type. We'll have a look at item type later, because I do seem to remember down the bottom, we've got this add and subtract. And they don't really belong here. They were an operation that was only used here at one point, But then I started using it in tests and that sort of thing, and I didn't get around to moving it because I like to finish a video. So let's move those to where quality is, because I think they feel like operations on quality.
We used move already.
We have used move already, OK. Right. Telephone call, really? OK, so add and subtract feel like operators. So let's try and make them operators. In order to make them operators, they are going to be so the operator doesn't add, it's plus, I think, isn't it?
Yeah.
So rename it to plus, but we've already had rename. We are going to make the quality a receiver, but you've already taken that one from me. But making it an operator with the yes is actually a refactor.
Does it count?
Well, yes, because it changes the code that's emitted so that it can be used as an operator later, right? All right, so now it is an operator, but it's not being used as an operator. So now we're going to have to go and find all the places it's used, which is slow. Now we've made it an operator, good for reasons. And now we can replace that with a plus, which is nice refactoring. Unfortunately, we've got to do it by hand for all of them, but we'll just suck that up, I think.
There's one more in tests.
Yeah.
Why?
Talk amongst yourselves. OK, right, here we go. Is that it? Probably.
Yeah.
OK. Now, quality is an extension function right by the class. That feels like I really feel it should be a method. And it also feels like there should be a refactor to make an extension function into a method. But there isn't. So we'll do it by hand. We'll just basically cut it out of here, put it into there, get rid of the quality bit. There's only one problem, which is that the extension function needs to be imported, whereas the method doesn't. So that now breaks all the places we've called, which you're going to fix up by hand, but is just a shame. Sorry?
But these are refactoring.
Yes. So, thank you very much. It's a good job of keeping me honest.
Yeah.
So that refactoring is effectively the way that you make an extension function into a method. But we had to do quite a bit of fixing up, so we are going to explore a technique to not fix up with subtract. We are going to extract the body of the subtract method, all of it, into its own little function, which appears to add no value.
Minus, right.
We're going to call it minus because that's the thing we want our operator to be called eventually, and we're going to do this little thing of making it an operator fun.
Operator?
And operator.
Public.
But we've already done that. We are going to make it public.
Never done this, if you want to.
I'm not desperate. Can we hold one in reserve?
For what?
Just in case, I don't know. We'll see how we're doing.
Yeah.
All right. So now we're in a position where all the code is still calling subtract, but we've got the actual operator living there. We can now move the operator up into there. Thank you, as a method. Now removing that, that all still compiles, and now if we do the one convert to operator on the minus in line 29.
Oh yeah.
Excellent. I don't know whether to claim the minus as well as the plus.
I think that counts as one.
Struggling. OK. So now, though, so everything is calling subtract, but subtract is exactly the right form we want. So if we inline subtract, then we fix up everything. And if we look at the places that it's now called, then they are all fixed up with operator minus.
Well, that's the fun one.
So I think I'm going to claim that as a refactor, like a compound refactor.
How is this refactor called?
Yeah.
Oh, what was
Sorry?
it?
What is it called?
What's it called?
I think that what you did, I think it was like what? Extract, modify, inline.
Extract, modify, inline,
It's
yes.
called Switcherooni.
Switcherooni. I think that's a really good name for it. That's the
Switcheroo.
name we should give it from now on.
Right.
OK, just looking at those calls
That
again.
was a funny usage. Right?
Oh, so we've got minus minus because of the way we inlined it. Interestingly, IntelliJ doesn't give us an option for replacing minus minus with plus, but I think
That counts.
that is actually refactoring. OK, so I think we've done quality to death. Let's have a look back at item type, shall we? OK, so item type is this strategy for how to update an item on a particular date. And we select an item type with this type for that goes through and says, if I don't have a sell by date, then I'm this undated item type. Otherwise, I'm brie or passes or various magical goods things from Gilded Rose. OK. Item type is Well, first of all, I don't like the local date. Let's just call that on, shall we? Because then it says update this on that.
It's a nice dialogue.
But you've already used that dialogue, so I can't claim that one. Thank you very much. Right, item type is an abstract class, and I can't remember why it's an abstract class, but I just didn't get around to fixing it. So it feels like there should be just make an abstract class into interface, right? But that isn't there. There used to be extract interface, but that died with K2. Will be resurrected, don't worry. So we're going to have to do this by hand, and actually it's quite easy to do by hand. You just change abstract class to interface.
Okay, it doesn't compile.
It doesn't compile because now, and there's no easy way to fix up that except just go through them and remove them. But as that was read to, no, I don't think we can count it. But I think we should count the whole, make it,
Don't interface.
Thank you very much. Okay, we're going to count that one. I think we're slowing down though. Okay, so we have replaced an abstract class with an interface. If I look in Type4, we are creating new instances of undated and Brie and so on every time, but they don't hold any state. So it's a bit of a shame to create a new object every time when really singletons would do.
Why did you do it this way?
There were reasons. I was young. So we're going to go about fixing that up. We'll try it with, is standard at the top first? Yeah, let's try it with standard at the top. Okay, so we're going to convert a class to singleton object. So if we just replace the class bit with object.
Oops.
Yeah. Now, that's all very well, but I mean, it's kind of succeeded, but it's broken the calls. Yeah. But we can fix the calls up again if we just write the function that has that signature. In fact, you could have alt-entered on that, and it would have done it for you. And they had that return the standard thing, and then we inline the function.
Okay.
So obviously, we didn't need to do it here, but had there been lots of others, that would have been nice. Okay.
Yeah.
But I think I'm going to claim that's convert class to singleton object is my ding. Right. Okay. But I don't think we actually got anything out of that otherwise, did we? Okay, slowing down. Okay. Undated. We'll try another track. I've never really understood the difference between an object and a val of object type, but we will have a look. So we're going to do this a bit of a sneaky way because we're going to get the function all in one go. So we're going to change that class to fun. That's it. And then we're going to make that a function, put the brackets in basically, and then say that is an object of item type. Okay. And now if we inline that fun. Now we're going to extract a variable of the object on the right-hand side. So that's going to be our val, our top-level val. Good, we'll call that undated, move it up to the top level, put it there, and now inline our undated, and we will fix up the code up above. There we are. So that is a val of an object type rather than an object of, yes.
Yes.
Right. Interestingly, we can convert a val of an object type to a object declaration.
Yeah.
Can we go back there?
But we can't go back. But we can do that ourselves. Let's do it. Okay, so just type the things that make it work. I can't remember. Yeah, basically, just type the val in there.
Undo?
No. We're gonna actually do the refactor ourselves, so we claim it. Val and yeah.
Okay.
Brilliant.
Well, I wouldn't count.
Okay.
Yeah,
we're getting close. Still not
39.
40. Okay. Okay. Returning to the top, please. We have an interface of we have an interface with only one function in it, and basically something with only one operation. It's really just a function, right? So and Kotlin has a cross between interface and a fun, and they imaginatively called it a fun interface. So let's make this a fun interface. And once we have a fun interface, then things can implement a fun interface just with this nice little syntax. We can convert it to a lambda. So that's rather sweet. And once we have a lambda, we can sort of,
there is a warning.
Okay, on is never used, rename. Brilliant. Love it. We can go either way, actually. We can put the type in on the left. We can put the, oh, no, we can't yet. We'll leave it alone. Leave it alone. OK. So, right. Sorry, find my place. We could inline undated. Yes, let's try inlining undated. If we inline undated, though, we still get this item type here. I feel like the compiler isn't really trying hard enough at this point because it knows it's aiming for an item type. I don't know why I have to put item type in here. There are other places I don't need to, but that's not a refactor and it's not helpful, so undo it. Right. Now we have a fun interface. We can actually work our way towards just having a function. And the way we're going to work towards that is we're going to rename the update just to invoke. Good. And now we're going to make that an operator, which I don't think we have, haven't we?
Did.
It's getting close. It's getting close. OK. That has the advantage, though, that now we can basically treat this. It's effectively a type alias. So let's just write the type alias. That is the same thing. There isn't automated refactoring. We're going to do we're going to call this refactoring convert fun interface to type alias, and we're going to brilliant. We're going to do that.
Delete this.
And now we should just be able to delete that.
Just delete.
There's only one problem, and that's here, and we can basically just shift that over there somewhere, and
something
life
like
will be good. Yes. 43. Brilliant.
What do I have?
OK. So that is convert fun interface to type alias. Let's go and find the callers of. Let's go and find the callers of that.
Doesn't work.
Yeah, that is a bit of a problem. Let's try and find the callers of invoke. Yeah, so that is one of them. So let's find the callers of that.
No usages.
But you Control-Alt-H will find them.
Should I get some tea?
OK, we'll give up on that. Let's.
We know where it is.
Where was it? OK, let's go and find it then. OK, so here we are. So now then we can take item type invoke. We can make that into the lambda.
Why?
Yeah, that's it.
Names are lost. Okay.
Yeah, well, I don't know why it loses the names, but you took the lambda one, didn't you? But what you haven't taken is remove the invoke. So now that is invoke, we can replace invoke with a direct call.
Yep.
OK.
Getting there.
I think we might make it. How are we doing for time? OK. Right. Now we have a plain old function type, right? And the question is, if we've got a plain old function type, why don't we just why don't we just have functions? So let's look at making this object, the standard one, into a function. Right. What are we going to do? We're going to take the body of that function, and we're going to extract it into a method at the top level. And if you were to call that standard, yes, and lowercase now, because that's the thing we're going to want. Brilliant, but we've used that as a refactor. Now, can we inline that standard, invoke?
You mean this standard?
Yeah.
Like
Can we,
inline
no. Can we inline the invoke?
You mean here?
Yeah. Try it.
You are adventurous, no?
No, OK. Can we call that standard : invoke?
Right.
Yes. Can we
works.
inline that?
Yeah, let's try. Mostly.
Yeah. Oh, well, I'm not quite finished, actually. Now we make that a reference.
Right.
Yeah. And then we are. And now we're just implementing the function.
Cool.
Brilliant. OK. That ding was that one. Yes.
Yes.
So close, so close. OK. What about the undated? Fold standard away so I don't have to look at it. This is a bit more, it's harder to do. But what we can do is we can make that lambda into an anonymous function. Yeah. OK. Now what we want to do is we want to get hold of that into sort of local variable. And the easiest way is to surround that with a run.
Is that easy?
Well, I'm not sure it is easy. Yeah. I'm not even sure it's a thing. How many have we got?
That's a 47. Yeah.
OK. Hey! Have we got any time left? Stretch targets? Have we still got time?
Yes, you have.
What? We've got 10 minutes left. Good grief. OK, carry on then. Right. Have I got room on my thermometer?
Let's blow it up.
OK, good. Right. So the run is now returning this anonymous. We should be able to take that fun, right, and make a variable out of it.
This is an expression, right?
Yeah. So we should be. We can't make an expression out of that. That's rather weird. OK. Can we say? Can we just make a val out of it?
Undated or something.
Yeah. And so we can return that, but it wasn't an expression.
Yeah.
OK. Well, I believe
it is.
The compiler must be right.
But it is.
That's no help to us, really. So what we're going to do is we're going to name the function. So instead of undated, yes, that's it, that thing.
But that's not an expression.
No, that's not an expression, which is a bit. No, but that makes sense, doesn't it? I think. You've gone wrong. Yeah. So we can do that, which I don't think is really helping. And at this point, you discover that you can have an underscore in an anonymous function, but you can't have an underscore in a function with a name. Don't understand it. But so now we have to do this, and then we have to mark that as unused. Yeah. But the clever thing now, finally, we can take that fun and move it to the top level. I'm not even bothered to ding now because it's OK, brilliant. Now, can we inline the run?
Nearly. Yeah, no. Manually.
It has worked in the past. And now, finally, I think we can inline undated. In fact, I'm going to ding a couple of times because I think there were 2 in there. OK, how are we doing? Let's inline item type. Have we inlined a type alias? Does that count? We've inlined things, but inlining type alias?
Not the type alias, no.
OK, inline it anyway. Brilliant. But I'm not sure it's clearer.
No.
OK, so let's extract a type alias.
Extract.
Yeah.
That you've done.
Is that a thing?
That you've done. Extracting type alias you've done before, right?
No, we made a type alias out of a fun interface.
Oh, yes.
Yeah. You can replay the tapes later.
No.
It's OK. Okay.
Yeah. No, I don't know. What should I do?
OK, so
go back.
Undo.
No. We'll do it by hand. I'm feeling fly. We got loads of time. Brilliant. OK. So there used to be extract type alias. Again, it seems to have disappeared. So we'll do it by hand. Basically, just do Control-G, find them all.
Right.
Brilliant. Replace them with the name of the type alias you want. You'd only ever did them in the current file anyway, so it's all good. So replace them with something called item type.
I think I should do this. Oops. Then item type.
Yeah. And then type and then just say type alias item type equals thing.
Okay.
Had to do it by hand, but we did it anyway. Right. And finally, I think, because we're going to allow these people to go home early, we've got all these Brie, Pass, and Conjured. Let's see whether we can do them all in one go with the magic of multi-select. Right. OK, open them up so people can see. Let's have a go. So we're going to take the class. We're going to call that fun.
All 3.
All 3 of them, yeah, that's it. Find them all, make that fun, and now we've got the names. The signature is really the one we want is over there by the invoke, so we can do that. Brilliant, yep. And now we've just got to brace too many, so I think if you were to match the brace or something, we could delete. Fantastic. Is that working? Oh, very nearly. OK, so now over here, go through and delete those, put those in, run the tests.
Nice.
And we're done.
Done.
Woo! So, yeah. You can find more of Duncan on YouTube.
Thank you.
There is also a book you might want to read about tidy first.
We're big on tidy.
Yeah, and that's one of the plugins I use a lot. I might have written it. And this was how many refactorings?
How many?
You did 49.
49 refactorings in 45 minutes.
And 45?
No, 50. 51. Yeah, 51.
OK.
There you go.
That will do.
Thank you very much.